Hey guys, y'all have been doing a great job with your IXLs. I'm so proud of you. And we only have 2 weeks left, so hang in there. We're almost done. This is some hard stuff, but you're handling it very well. We're going to do some more factoring. I know everybody's so excited. Before we get to our lesson for this week, let's go over some stuff that we've talked about in the previous weeks. So if I'm going to multiply this monomial times a binomial, we should know by now that we would just distribute this out. So I would multiply 2x times x to give me 2x squared, and then 2x times 3 would give me 6x. Okay, so basically this monomial and binomial are the factors, and when I multiply them together I get this entire product. Okay, last week we worked on factoring out a monomial. So if I was to factor this product of 2x squared plus 6x, we would have to find the greatest common factor, and I can tell that the greatest common factor, GCF, would be 2x. So I could factor that out of each term. 2x squared divided by 2x is just 1x, and then 6x divided by 2x is 3. So you can tell whenever we factor it and go backwards, we get the exact same thing, 2x times x plus 3. Okay, so that's only with the monomial. This week we're actually going to be factoring what's called a trinomial. So let's take a look at some examples. So now if I want to multiply two binomials together, we know we can use the distributive method or the box method. Let's go ahead and review both. So I'm going to multiply the x times the x to get x squared, x times 3 to give me 3x, 2 times x is 2x, and then 2 times 3 is 6. So whenever I combine my like terms, let me just erase this, it would turn into x squared plus 5x plus 6. Okay, let's also go over if we were to multiply this using the box method, because we're actually going to use the box method to help us factor. So same thing, I'm just distributing each one of these terms to each other. X times x is x squared, x times 2 is 2x, x times 3 is 3x, and 3 times 2 is 6. So as you can tell, I would have 1x squared, combine 3x and 2x to get 5x, and then plus 6. So my two factors would be x plus 2 and x plus 3. We can also see those factors as the length and the width of this box. And my product is x squared plus 5x plus 6, which is also found within the box as well. X squared plus 5x plus 6. So on the next page, we're going to look how to start with the product and then work backwards to figure out the two factors or the two binomials that I use to multiply together to get the product of x squared plus 5x plus 6. So if I want to factor this trinomial, x squared plus 5x plus 6, okay, we already know just by the previous page that my factors would be x plus 2 times x plus 3. Okay, but let's pretend we don't know that. And we're going to try to figure out, well, how could we find what those two factors are? So the first step is going to be to draw a box. As you do more and more of these, you won't need the box anymore, but this is a great method to help you stay organized and to check your answer at the end. So normally we would know that the x plus 2 and x plus 3 would be out here, and then we would fill in the box to get that trinomial. But now we're working backwards. So now we don't know the two factors, the length and the width. We know what goes inside the box. So After I've done my step 1, I need to go to step 2, which is put the first term in the top left. So my first term is x squared. And the last term in the bottom right. And the last term is 6. Now I just need to figure out what goes inside of this diagonal. And remember that this diagonal makes up this middle term of 5x, because when I add these two numbers together, it's going to have to equal 5x. So now we need to move to the third step. Multiply the coefficients of the first and last terms together. So the coefficient of the first term is 1, because this is really 1x squared. You just don't have to write the 1. And then the last coefficient is 6. So we're going to multiply the first and the last together. So we're going to multiply 1 times 6. So 1 times 6 is 6. And we need to find the factors of 6 that add up to the middle term, which is 5. Okay, remember my middle term is 5, which is in green. So let's start thinking of some factors of 6. I know that 1 times 6 is 6, and 2 times 3 is 6. But whenever we add these, we want the ones that will add up to 5. So if I add 1 and 6 together, that equals 7, which is not what we want. But if I add 2 and 3, that equals 5. So I know that the two factors that I need to use would have to be 2 and 3. So we're going to put those two factors in the diagonal, because I know 2x plus 3x adds up to 5x. Also, when I multiply 2 times 3, it gives me 6. I know this probably looks really confusing, but the more you do it, the easier this will become, and it'll just become like second nature. So let's go ahead and erase some of this right here, and then we'll go ahead and redraw this box and start factoring it out. Alright, so I just cleaned it up a little bit. I still have x squared, 2x, 3x, and 6x within the box, okay? Now I'm going to factor out each row and each column, and I'm taking out the greatest common factor of each. So let's go ahead and look at this first row. I'm going to circle it just so you know which one I'm talking about. What does x squared and 2x have in common? What's their greatest common factor? Well, they each have an x. Now let's go to the next one. What's the greatest common factor of 3x and 6? And that would be 3. Now we're going to move to the column. What's the greatest common factor of x squared and 3x? And that is also x. And then finally, the greatest common factor of 2x and 6 would be 2. So now you can see how we get x plus 2 and x plus 3. So since the 2 is positive, there's really like a plus here. And since the 3 is positive, there's also a plus here as well. So I can get the length and the width. My two factors of this box would be x plus 2 times x plus 3. Okay, and we know just from the previous page that those were the two factors we got whenever we multiplied them together. It would give us x squared plus 5x plus 6. And by using this box method, you could easily check yourself and make sure if you multiplied it back out that you would get exactly with what you started with. Alright, one other thing I want to point out is I want you to look at the factors that we originally circled in blue. Okay, let me circle them right here. 2 and 3. And then what do you notice about the 2 and 3 in our factors? Okay, so keep that in mind, and I want to see if you can figure out a pattern as we do more of these together. So let's start looking at some IXL examples. So for this example, we are going to find the two binomials that we would multiply together to get p squared plus 8p plus 15. So now we're using p's instead of x's, so I know a p would be my variable. It's still all going to be positive because all of these signs are positive. But I have to figure out what would be the factors of 15 that would also add up to 8 to get these last two numbers in those binomials. So let's go ahead and go through the box method again and get our answer. Alright, if you need to go back to the previous page, you can look at those steps just to help you. If you need to write them down, go ahead and do that. But let's go ahead and set this up. So I need to draw a 2x2 box. I'm going to put the first term, which is p squared, in the top left, the last term, which is 15, in the bottom right. And then remember, in order to get this diagonal, both of these numbers have to add up to my middle term of 8p. So in order to do that, we have to multiply the first and the last term together. So my first and last term is a 1 and a 15. So I'm multiplying 1 times 15, which is just 15. So we're going to find the factors of 15 that add up to a sum of 8, because 8 is my middle term. Whoops, just 8. There we go. Alright, so let's list some factors out of 15. 1 and 15, 3 and 5, and that's it. So if I add 1 and 15, I'm going to get 16. That one does not work. But if I add 3 and 5, I get 8. And that does work. So I know that my factors that I need to use are 3 and 5. So I'm going to replace this diagonal with a 3x, not 3x, with the 3p, because our variable is p, not x, and 5p. So now the last step is just to factor out each row and each column of this box. So let's start with this first row. What's the greatest common factor of p squared and 3p? And that would just be p. Then the last row, the greatest common factor of 5p and 15 is 5. And then move into the column. They both have a p in common. And then the last column, the greatest common factor of 3p and 15 would be 3. So our factors would be p plus 3 and p plus 5. And it doesn't matter which order. You could have also have written it as p plus 5 times p plus 3, and that also would be correct as well. Okay, once again, what do you notice between our factors of 15 that we selected, 3 and 5, and our answer, p plus 3, p plus 5? Okay, keep that in mind. We're going to do another example. Okay, now we're moving to a problem where we have a negative and a positive. So let's look at this example. I need to find the two factors of f squared minus 9f plus 20. Alright, so first thing, I'm going to draw a box again. And I put my first term, f squared, in the top left, and my last term, 20, in the bottom right. And then I need to figure out what two numbers would go in this diagonal to add up to negative 9f. So let's go ahead and make our table. I need to multiply my first term of 1 times my last term of 20. 1 times 20 is 20. So we're finding the factors of 20 that add up to a middle term of negative 9. Alright, so let's just think of two factors of 20 that could possibly get us to 9. Okay, I know 1 times 20, but there's no way I could get that to equal 9. 2 times 10, probably not going to work, but maybe 5 and 4. Okay, 5 times 4 equals 20, and when I add 5 and 4 together, I get positive 9. But this time we want it to equal negative 9. So what is a way that I could get positive 20 but still have a 5 and a 4? Well, we should know that two negatives multiplied together would give us a positive answer. So I could multiply negative 5 times negative 4 to get positive 20. But then when I add them, it gives me a negative 9, which is what we want. So I know that my two factors would have to be negative 5f and negative 4f. Now we just need to factor out our box. Okay, this time we have negatives, so here's another rule to keep in mind. You're always going to use the sign that's touching the outer edge of the box, okay? So whenever I factor f squared and negative 5f, since f squared is touching right here, it's going to be positive. F squared and negative 5f both have an f in common, and it's going to be positive. But here, since the negative's touching the outside, my answer needs to be negative. So you're always going to go with what is touching the outermost edge of the box. So the greatest common factor of negative 4f and 20 would have to be negative 4. Move into this column. Since the f squared's touching the outer edge, it's going to be positive f. And then the last column, since this negative 5 is touching the outer edge, it's going to be negative. And the greatest common factor of negative 5 and 20 is negative 5. So my two factors would be f minus 5 and f minus 4. Okay, once again, what do you notice from f minus 5 and f minus 4 to these original factors that we did down here? They are the same. So if you have a 1 as your leading coefficient, which is exactly what all of these problems will be, you really don't have to do the box method. All we could have done is just down here, I knew that my two factors were negative 5 and negative 4, and my variable was an f. So I could have just written out my factors like this and saved myself some time and not had to do the box method. So let's go ahead and try that when we do the next problem. Alright, so this point, we don't have to do the box. If you want to still keep doing it, you are more than welcome to. But let's just save ourselves a little bit of time and skip the box. So we can do that because the leading coefficient is a 1. This only works whenever your leading coefficient is a 1. So now I just need to multiply the first and the last terms together. So 1 times negative 15. Don't forget that negative. 1 times negative 15 is negative 15. So I'm looking at the factors of negative 15 that add up to the sum of the middle term, which is negative 2p. Alright, so let's think of some factors of negative 15 that would also add up to negative 2. Well, the first thing that pops into my head is 3 and 5. But 3 times 5 is positive 15. So in order to make this negative, I need one of these numbers to be negative. So these are my two combinations that I could use to get negative 15 with 3 and 5. Now let's add them together and figure out which one would give me a sum of negative 2. Negative 3 plus positive 5 is positive 2. So that one does not work. 3 plus negative 5 is negative 2. So those two factors work. So instead of drawing your box, all we have to do is just write p plus 3 for one factor and p minus 5 for the other factor. And that's your answer. Okay, remember you could have written it the other way. P minus 5 times p plus 3. Both answers are correct. Okay, you could multiply this back out and check yourself and make sure that when you multiply this, you should get what you started with, p squared minus 2p minus 15. I know this is a long video and we've done lots of examples, but I just want to make sure you have plenty of examples to use before you start doing your iExcel. Okay, let's try this one. I need to factor w squared minus 10w plus 24. So once again, my leading coefficient is a 1. So we don't have to do the box method. I can just multiply 1 and 24 together. So I'm looking for the factors of 24. that add up to the middle sum of negative 10. Alright, so let's start thinking of some factors of 24. 1 and 24, but that's not going to add up to 10. Maybe 2 and 12. Okay. Maybe. Let's keep thinking of some more. 6 and 4. That could definitely add up to 10. So let's stick with 6 and 4 because I know 2 plus 12 is 14, so we're definitely not going to want that for now. 6 plus 4 equals positive 10, but we want it to equal negative 10. So in order to do that, I know that both of these factors have to be negative because negative 6 times negative 4 equals positive 24. And then whenever I add them together, it equals negative 10. So my answer would be W minus 6 times W minus 4. Okay, if you want to check it, multiply it back out and make sure you get exactly what you started with. W squared minus 10W plus 24. Alright, we finally made it to the last question. Woohoo! Here's our last example. We need to factor q squared plus 36q minus 37. So let's multiply 1 and negative 37. So I would get negative 37 for my factors, and it needs to add up to the middle term of 36. Well, thankfully 37 is prime, so the only two factors are 1 and 37. Okay, I need one of these numbers to be negative because a negative times a positive would give me a negative 37. So let's figure out which one needs to be negative. If I add negative 1 and positive 37, that would be 36, which is what we need. And just to check the other one, if I did 1 plus negative 37, that would equal negative 36, which is not what we need. So my two factors would be negative 1 and positive 37. So whenever I factor this, I would get q minus 1 times q plus 37. Like I said, always, always, always check yourself. If you were to distribute this back out, make sure you would get exactly what you started with. Alright, I know that was a lot, but y'all can do that. Please call or text me if you have any questions with your assignment for this week.